Hello friends, in this video I'm going to explain you about the introduction to linked list. It is in the algorithm and data structure in our syllabus. It is in unit number 3. See, as if it belongs to the data structure, and we are very aware about the data structure right now. The data structure is a logical representation of data and operations that can be performed on the data. As we know that data structure is divided into two different parts, majorly linear data structure and non-linear data structure. In linear data structure, it is an order of data elements. They are arrays, stacks, queues, and linked list. Ultimately, this linked list belongs to linear data structure. What is linked list? Linked list is a linear data structure. As I already said, it contains node in which each node contains two parts. A particular node contains two parts, that is data part and link part. The data contains the elements or the values, and the link contains the address of the next node. Linked list is a sequence of links which contains elements or items, we can say. Each link contains a connection to other link. That's why it is called it as the link. Linked list is the second most used data structure in an array. There are some important terms that we are going to use in this linked list. First is link, in which each link of a linked list can store the data called an element or item. Each link of a linked list can store a data called an item or element. The next is we can use the next always, that is each link of a linked list contains the link to the next link that means it is having the address of the next link, called as next. And the linked list, a linked list contains the connection link to the first link, called as the first. Look at the screen. It is limitations. There are certain limitations of arrays. Arrays are very simple to understand, and elements of an array are easily accessible, but arrays have some limitations. Arrays have fixed dimensions. The dimensions cannot be changed in arrays. Once the size of an array is decided, it cannot be increased or decreased during execution. Whatever that size, as if we have decided it at the start of the algorithm, it may not be changed, it may not be increased, it may not be decreased during the whole execution. Array elements are always stored in continuous memory location, whereas operations like insertion and deletions of the array are pretty tedious, pretty difficult in fact. To overcome these limitations, we use the linked list. Linked list can be visualized as a chain of nodes where each node points to the next node. It is a collection. Linked list is a collection of elements called nodes, as I already said. Then each node contains two parts. They are data part and link part. See, the whole orange box is the node, whole orange box. But that whole orange box is a single node, and that single node is divided into two parts. First part is data and another part is, say, link. First part is data and another part is, say, link, in which, see, the data value is 14 and the next value, it is the link or the address location of the next node. See, 14 is the element or value which is having the address location of next element 100. It means it is having the address location of the next element or next node which is located at the location, say, 100. and ultimately it points to that 100 node which is having the value 30 and which again carries the address location of the next to next node, that is 400. Ultimately 14 is a value, 30 is a value, 42 is a value, or we can say 14 is an element, 30 is an element, and 42 is an element, or we can say 14 is a data, 30 is a data, or 42 is a data, which is also having the address location 100, which is also having the address location 100, 400, and so on respectively. In that case, in that case, 14 is having the value, having the address location 100, pointing towards the 100, that is 100 location is having the value say 30 or element 30 or data 30, and that 30 is having the location say 400, 400 is having the data 42, and after that this may be the last node. Why? Because that 42 node or that last node, it does not having the any address of any different node. It gives as it shows that it is n means null, n stands for null. The above figure shows the example of marks obtained by different students that can be stored in a linked list. We can say that here n stands for n stands for null, where null indicates the end of the node. What are the linked list? A linked list is a linear data structure. Nodes make up linked list. Nodes are structures made up of data and a pointer to another node. It usually the pointer is called as the next node. Look, 5, 10, 20 and 1. It is the header. Yeah, it is the header. Initially it starts from say the value or the element 5, then it is having the address of next node, that is 10. That 10 is also having the address of next node, that is 20. 20 is also having the address of next node, that is 1, and 1 is having the address of last node, that is null. Information field, or we can say it as the data, is always proceed at the left side of the node, and the right side of the node is carrying the link field or address of the field. Then so there is certain difference between arrays and linked list. Whereas in terms of size, array is having the fixed size, or resizing is expensive in arrays, whereas in linked list it is of dynamic size, and insertion or deletion are inefficient in terms of arrays, where elements are usually shifted, and in linked list insertion and deletions are efficient because no shifting is there. In terms of arrays, random access is there, that is efficient indexing we can perform, whereas in linked list no random accessing, not suitable for operations requiring accessing elements by index such as sorting. We cannot perform any random access in linked list because it is having the address location of the next symbol, next node wherever it is pointing. No memory waste in arrays, whereas comparatively it requires much more memory in linked list as compared to arrays, because it is having the address location, it may having that values along with it, and it is also having the element in with it, so it may require certain amount of memory, more memory. Sequential access in is faster in arrays, whereas in linked list sequential access is quite slow. Next, there are certain advantages of linked list. They are dynamic in nature, which allocates the memory whenever it is required, and in insertion and deletion operations can easily be implemented in linked list. Linked list can contain a link element called as first, whereas each link carries the data fields and a link field called as next. Each link is linked with its next link using its next link, as I have already discussed it in the previous slide. Last link carries the link as null to mark the end of the linked list. It may be the end. We can show it with the help of say the n. We can perform various operations on linked list: insertion operation, deletion operation, as well as reverse the linked list. We can also reverse the linked list as well. We can perform these three operations in the linked list. We can display certain element with the help of linked list. We can search any element into the linked list with having the address values or with having the address in the linked list, as well as insertion and deletion operation can easily be implemented in linked list. Stacks and queue can easily be executed in the linked list with the help of linked list. Linked list can reduces the access time. These are the various advantages of linked list. There are certain disadvantages of linked list. As we know, it requires certain amount of much memory as compared to arrays. The memory is vested as pointers required extra memory for storage, cause uh, one node is completely having it divided into two different parts. First is the actual element and another one is the uh, memory location of the next element. So quite comparatively, the memory is vested as pointer required extra memory for storage. No element can be is accessed randomly. This is the major disadvantage. No element can be accessed randomly. It has to access each node sequentially. We cannot access the linked list in a random manner, whereas reverse traversing in the linked list is difficult. We cannot move in a reverse direction. There are uh, certain applications of linked list. The linked lists are used to implement stacks, queues, and graphs, etc. Linked list can let you insert the elements at the beginning as well as at the end of the list. In linked list, we don't need to know the size in advance. These are the certain applications. In the next video, we'll see about the various different types of linked list. Thank you for your patience hearing.